Can you repeat? I can't hear.
I believe she said that she can't contact with Nash.
Oh, okay. Any news about him?
We
Guys?
don't know lah, cause he usually also not joining our studio class also. Any
I
class.
see. Oh, okay.
Yeah. So we long time didn't see him already actually.
Wow. That's quite surprise. Because now we are left with 5% active students for this class. That's quite hard.
No choice, you have to do 2 group.
Yeah, looks like that lah. But as of now, since we are already, up to this stage, it should be continue to for this stage. For the next one, we shall change. Okay. If that's so, let's try group Damien and Nazira to present, and for Mariam, we shall discuss after all presentations. Okay.
All right, sir.
Okay. Okay. Here you can start now.
All right. Wait, I share screen.
You can.
So can you see it?
Yes, can. Yeah. Nice.
Okay, everyone. So today our topic is about noise effect to human. Our research location is at Beijing, China. So what is the environmental noise pollution? All the sound that interfere with people's normal rest, study, and work and hinder human life and production are collectively referred to as noise, such as the roar of machinery, the sound of various machines, the sound of whistle, the noise of people, and all kinds of sudden sounds are all noises. Noise does not depend solely on the physical properties of the sound, but is also related to human living conditions and subjective feelings. According to Chinese standards, noise in residential area does not exceed 55 decibel during the day and 45 decibel at night. On both sides of the road, it does not exceed 70 decibel during the day and 55 decibel at night. The comfortable volume in people lives is generally around 50 decibel during the day and 30 decibel at night. Okay. The impact of the noise to humans, 0 to 50 decibel is comfortable and like whispering. Then 50 to 90 decibel will disturbing some sleepiness and will cause sadness and anxiety. When the decibel is reached 90 to 130, you will feel your ear will pain and your ears will itchy. And if above 130 decibels, it will rupture eardrum and will cause deafness. Noise can also damage eyesight, cardiovascular system, and nervous system. People who work in a noisy environment for long period of time can cause neurasthenia syndrome such as headache, dizziness, tinnitus, memory loss, vision loss, and others. Next. Sorry, sir. Sorry. Jack, we can't hear you. He have mic problem.
I see. My problem.
Yeah, because he turned on his mic, but we can't hear him.
Can hear me now?
Oh yeah, Candy.
Here is Beijing noise mapping. The noise map is a data map that reflects the city's noise level and is generated after integrating, analyzing, and calculating information such as noisy source data, geography data, building distribution, road conditions, highways, railways, and airports. In this map, the noise on both sides of Beijing's road traffic arteries exceeded the maximum limited of 70 decibels controlled by the state from morning to night. Among the southwest, northeast, and other places have especially become the severe disaster areas affected by noise. On this map, the noise pollution status of the main road section is marked with 5 colors. The road section with the lightest noise is lower than 68 decibels, and the section with the highest noise is higher than 74 decibels. Next.
What color is the high decibel?
The right color.
The red color.
Yeah.
The green and blue is not, there is no noise.
Yeah.
Sorry, can't hear you.
The green is the lowest one.
Yeah.
And the yellow is the moderate. And the red is the highest one.
Okay. Okay.
So, sir, can I continue?
Yeah, I can hear.
The next is the ways to control the noise. And in buildings, the measures taken to reduce noise are mainly sound insulation and sound absorption. Sound insulation is to isolate the sound source to prevent the noise generated by the sound source from spreading indoors. Plant trees on both sides of the road to insulate the houses on both sides. In a building, a sandwich structure made by separating multiple layers of dense materials with porous materials will also have a good sound insulation effect. As you can see, the lower picture is actually the sandwich structure. In order to eliminate noise, the commonly used sound absorbing materials are mainly porous sound absorbing materials such as glass wool, mineral wool, expanded perlite, and perforated sound absorbing panels. The sound absorption performance of a material depends on its friction, flexibility, porosity, and other factors. In addition, the lawns and trees around the building are also good sound absorbing materials. And an elevated road near the Beijing Zoo is about 1,800 meters long. In order to protect the surrounding residents from noise disturbance, soundproof screens are installed on the bridge deck. This is the first fully enclosed soundproof tunnel in Beijing. And that's all from us. Thank you, sir.
This looks good. That's all there.
Yeah, that's all.
Okay, so that. In your studies, do you found I mean, when you in the studies that you said that the lowest is 67 decibel, is that during the which hour? Because you didn't mention the quietness level, because from the studies I felt that there is no quietness effects or level in the city. You only mention lowest decibel area.
So can you repeat the question again? I don't get it.
A quietness level in the city. The one that show map just now. The other one. Yes. In this map, it shows noise pollution level, the highest and the lowest of pollution, but it didn't have uh, probably the quietness level, because quietness level uh, will be determined during the least active hour. From this one, I think it is the time when it is the most busiest.
Yeah, true. We do have the quietness one, yeah.
Yeah. So I think you miss out that part, the
Yes.
quietness. All right. So if you have, if possible, please update the quietness level.
Okay, sir. Can.
Okay. I think yeah, that's all for the comment for your presentation.
All right, thank you, sir.
Okay, good. We shall move to the next one. Nazira, you ready?
Yes, sir.
Okay, you can start sharing.
Can you see? Can you see, sir?
Yes, can.
Oh. People living in the large cities are constantly exposed to the noise, which is bad for health. Noise pollution is the pollution of the environment with various sounds of anthropogenic origin, which have the terminal effect on the activity of living organisms. Noise pollution includes urban road network, construction equipment, industrial facilities, household noises, and air transport. If the body exposed to the constant noise exposure above normal, then diseases of the nervous system, problems with the heart, psych, as well as hearing loss may occur. Architecture acoustics are essential in ensuring sounds are transmitted clearly and effectively. They matter when it comes to keeping things quiet in places like libraries or museums. Architectural acoustics involve designing a building to control how sound waves reverberate off its interior in such a way as to maximize clarity, amplifying sound in areas where it's appropriate to do so, and reducing noises level where doing so is beneficial. Requires taking into account a number of aspects, including the room shape and the material used in the construction, particularly their sound absorbing and boosting properties. Mechanical system can also play a part. Noises from fans, motors, and other mechanical components can produce unpleasant distractions and even interfere with communication transmission. Research even has found there are actually an optional room shape for achieving perfect acoustic. It's rectangular and constructed using the Golding ratio, which is 8 feet by 12.8 feet wide and 18.70 feet long. In terms of material, softer materials like carpets, fiberglass, insulation, and foam padding tend to absorb sound well, while harder materials like concrete and brick tend to reflect it. Wood can reflect sound well, but if holes are drilled in it, it also can absorb sound. Mechanical components can be placed away from rooms to minimize acoustic. Soundproofing can also be used in insulation and technology. Sound absorption is the quality found in different materials that reduce reverberation times by absorbing sound energy and reducing sound level. By eliminating unwanted sound, these materials can improve sound quality in a room. Sound waves bounce off surfaces in interior spaces, such as ceiling tiles and wall panels. Noise buildup and reflects back on itself, reducing it clearly and making it harder to understand. It's different from an echo in which there's a delay between the original sound and its fainter answer. And about the quietness level in the city, in 2007, after 30 years in New York, overhauled its noise ordinance code to set specific level on unreasonable noise and prohibit certain noises. This includes setting limits on everything from barking dogs, 5 to 10 minutes during the day, and making constructions develop noise mitigation plans, including outfitting equipment like what is that, jackhammers and other impact devices with noise-reducing mufflers, or having portable street barriers and limiting the hours when the construction is able to happen. But for businesses such as restaurants and clubs, the noise code still only can regulate noise emissions, the output or source of noise, rather than how much noise a given person is experiencing in the establishment. A restaurant noise can't exceed 42 decibels as measured from inside nearby residents and 7 decibels over the ambient sound level of the street outside the establishment at night. According to the code, but there are no regulation preventing levels of noise inside that we know can make us sick and hard of hearing. Meanwhile, there are more complaints to the city, 311 hotline about the noise rather than any other issues. Yeah, that's all. Thank you.
Do you have the studies on the city that you are doing, New York?
What do you mean, sir?
Yeah, you are doing New York, right?
Yeah.
So, you know, you are just giving writings. You didn't show any maps about where is the noisiest area or the quietest area in the city.
Understand.
Because you know, New York is a very unique city. They have a small um, forest. It's not forest lah. It's like a very beautiful garden that is allowed wild animals in that area, right? So how that you know that gardens help to absorb the noise of the city? So this is the thing that actually we want to learn. That you are doing is not enough.
Okay. Understand.
So can you find more infos about that?
Yeah, sure. Should I stop my sharing?
Yes. Network quality. So for Mariam, you don't have any presentation today?
Yes, sir.
How should we do this? So this is the very hard for me to do this. Okay, so try to contact again with Nash, and then if he's still not around, please let me know. Please contact me and let me know the situation. Okay. And then
Okay, sir.
please also let me know as soon as possible, because if you cannot work with this, then I will allow you to work together with Nazira. But I must know what happened to Nash. If you can contact him, that's better. All right. Just give me 1 minute. I need to do something. Then we shall continue with more lectures. So, one question. How does plant really help in noise absorption?
Rough bug ethic. Rough
Okay.
bug ethic. Those stems, branches can absorb, right?
Yes. The leaves also can absorb.
Yep.
Okay, give me 1 minute to prepare the lecture. Then we shall continue with lectures. Okay, so can you see this screen?
Yes, sir, can see.
Okay, so we are already in the time to learn about acoustics. Okay, your presentation just now are all good. However, in this lecture, we will learn more detail about sound, acoustics, noise, and quietness. All right. So number one, when you see the data about decibels, you already know decibels is the measurement of sound and noise, right? Do you able to see the measurement of quietness? There is no such thing as measurement of quietness, right? Because this is only same meter which is using decibel to receive the, if the noise is high, then the number is high. If the noise is low, then it becomes low level, low numbers in decibel. So it means that quietness is actually the absence of sound. Absence of sound is the quietness. So that's why it is cannot be measured directly. It must it is only absence. So sound, when we learned just now from the slides from Nazira and also Damien and Jack and Brian, they mentioned that even sound can cause blindness. Why it is happened that way? Is because of, from the definition itself, the sound is the sensation caused by vibrating medium as is act to human ear. Human ear is the thing that can hear it, but because of vibration, um, vibration is it is able to move from in the air. This vibration, it also can move in other material. So if it is on the liquid, for example, like in this picture using the water, you can see the vibration on the water. But this vibration, if it is in the on the water, you cannot hear unless you are inside the water together with it. Then you can hear the sound in the water. Means your ear must be submerged in the water also. Otherwise, if you are outside of the water, you cannot hear the sound inside the water. So there are attributes of sound which is similar slightly similar with attributes of light. They have wavelength, they have frequency, they have velocity and sound power. But light, it is light power. And then the strength or magnitude is the loudness of sound. In light, it is the strength would be the change of uh, brightness. So with wavelength, we can see from the distance of sound travel. Frequency, we can see the number of time that a cycle of compression. Velocity, we can see from the depends on the transmitting medium. Sound power is the output of sound source. The strength and magnitude of loudness, you can listen from the sound pressure and sound intensity. So wavelength is the distance between successive crests of a wave, especially points in a wave, sound wave, or electromagnetic wave. So the measurement is in meter. Sorry, this is a symbol is, I can't remember this symbol. Never mind. Frequency, the rate per second of vibration constituting a wave either in a material, as in sound wave, or in a electromagnetic field, as in the radio waves and light. So it is under measurement hertz. So regarding this, we just learned what are these about. So this is the frequency, and this is the amplitude of power, which is the height of this wavelength. Frequency is from this start to the another start. Wavelength is one complete curve. Velocity is the product of wavelength and frequency. So it becomes velocity. So an air is usually taken as 340 meter per second, but it varies with the temperature and humidity because it is faster in warmer temperature, less dense air. The unit of velocity is in meter per second. So this is the sound velocity during in different medium. Air, it will be 330 meter per second. Wood, it will be faster, 3,400 meter per second. Water, 1,400 meter per second. Concrete, 3,100 meter per second. Steel, 5,000. Lead, 1,200. Glass, 5,500. And then hydrogen would be 1,260 meter per second. So these are all different speed, right? So have you, these are all very fast. We can't even think the speed of this because from our naked eye, we can only see anything slower than this number. Faster than this number, we almost cannot see. Even this number, the speed of sound alone, we almost cannot see the speed. It is too fast. Have you watched movie Eternals? Not, I guess not. Maybe next week. Never mind. Continue. Attributes of sound. This measurement of sound output power is measured under watts. Jet airliner would produce 10,000 kilowatts of sound power. Pneumatic riveter accelerating motorcycle would produce 1 watt. And then 50 kilowatt electrical axial flow fan is 0.1 watt. Large orchestra is 0.01 watt. Food blender, coffee grinder is lower sound power. And then conversational speech is much lower sound power, which is only 10 to 5 watt. The strength of sound is measured by sound pressure, sound density, and intensity. Pure tones and broadband sound. Pure tones definition is a tone with single frequency, no harmonics. This is a sine wave, and this type of sound can only be generated electronically. So pure tones, if you are, how to say this? If you were born older than, if you are older than now, means you were born earlier, you may saw phones that is called pure tones. Pure tones which generated electronically. It's like Nokia 3210, 3310. Those are the time where the sound of pure tones. And then broadband sound is the sound that contain many frequencies. This is different, but there are other harmonic tones is also called polyphonic tones. Those are the, for example, phones like Nokia 8810. Those are the starting of the what I mentioned just now. Harmonic is the polyphonic tones. Polyphonic tones is harmonic, is have a lot more sound in it, a lot of frequencies, different sound, but it's not broadband sound. Broadband sound is different. So with that time, the sound of the phones are almost all similar. But now you can change to any sound. You can even put music as your phone ringtone. Propagation of sound, you must able to do it differently. One is sound wave, another one is propagation medium, by longitudinal wave and transverse wave. But for the propagation medium, you can use air, water, or solid. Wait, what happened? Hi.
Yes, I okay here.
Okay. Oh, it's on my side. Saggy internet line got abrupted. Can you guys hear me and see the screen?
Yes, sir.
All right. Um, okay. So this is the transverse wave and longitudinal wave. It's almost similar, but it is different in certain ways. I also cannot distinguish the difference. Maybe if it is moved, then we can see the difference of this sound wave. So sound field is the volume of space where vibration emitted by a source are detectable. Depends on the sound power, directional characteristic of the sound source, and the properties of any medium it passed through, is reflected or absorbed or diffused. Sound field, free field also is different of propagation. The effects of boundaries are negligible where there are no significant reflection. When there is no reflections, it can uh, become louder. Propagation of sound also can happen when you are sitting in a place where there are a lot of solid walls, where the sound bounce each other from either sides of the wall. It creates a big echo. Sound energy produced by sound source depends on the distance and observer with sound source. So the sound, for example, start here, and you can hear surrounding it. Near field and far field would be different. So this is how it looks like. It is called inverse square law. So if the sound strength like this is the area of the sound that you are hearing. But when it is in the sound becomes bigger, for example, like here, distance from the source to the this A direction is R, and when it is double 2R, the size of area of sound you can that can be heard is 4A. It's like almost 4A. It's like quadruple the size of the area that can be heard. And then when it is 3R, means the distance is from the source is 3 times uh, further, then the area of sound can be heard is 9 times of the first row. So it becomes a bigger area. Many people can hear it. But the sound strength depends. If the source sound strength is low, then at the 3R, it's very faint of sound. But if the source is loud, means that even at the 3R, you still can hear clearly. Okay, acoustic shadow occurs when there is a wave front reaches an obstacle. The original pattern of waves continues above the top of the obstacle. The example like this is called sound acoustic shadow. When there is an obstacle where uh, you cannot absorb. I mean, this obstacle is absorbed or reflected, then this acoustic shadow happen. This area is become is not totally quiet, but it is very low in terms of whatever you are supposed to hear. However, if it is under low frequency, the sound wave will be diffracted. When it is diffracted, it causes diffraction. When it is diffraction, you still can hear the sound. However, the strength is different. This will happen in only low frequency and no acoustic shadow happen. So you still can hear things if it is you are sitting on the other side of this, even this area. So this is example of simple acoustic system. You have the sound source and then conveying medium and then the receiver. The receiver must be your own ear. The medium could be anything. Sometimes air. Most of the time it's about air, but it is either thick or thin air. Conveying medium, receiver, we'll just talk about it. Okay, so this is the thing that you call I can't remember the call name. It's like a fork, right? That you, when you hit it, you will hear a vibration sound. If you put this in the water where it's still vibrating, you will see that the water will be it's being shaken. So sound transmission is airborne, structure-borne, impact, or flanking. Airborne and structure-borne sound. These always related together whenever it is from one source. Because from the airborne source and impact sound source is usually can be transferable. Okay, it means that when you are doing bouncing a ball, the impact sound happen. So, and when this impact sound happen, the sound can travel through the structure bond sound. So you will hear on the other side of the wall that there is some people playing a bouncing ball. So even when you are the person talking on the other side of the wall, with certain condition, the other side of the wall can hear either through the airborne transmission through wall or through the structure bond flanking transmission via ceiling surface. So this is the definition: airborne, structure bond, and impact sound. Flanking sound is when the sound reach the point of interest or by path other than through the separating partition. In building, we are connected with airborne sound or structure-borne sound. They are transmitted by the building fabric. Building fabric is the building structure. Okay, in a building there are wall, column, slab, roof, right? So building fabric is the main structure. Main structure in building is actually the column, the beam, and floor. Wall is actually nor depends on what kind of structure it is. But wall sometimes is not considered as building fabric because they have many components in it and it's not directly connected to each other. Room acoustic. In a room, when a sound source is switched on and it operates at a steady level, the intensity of sound field increases until the energy absorption rate equals to the energy input rate. At this point, equilibrium would exist and the sound field would be steady. When the source is switched off, the reverberant sound field would persist for a little time as it gradually decays. Reverberation. I think both group did mention about this reverberation. But I think siapa namanya Nazira did mention more about reverberation. Sorry. Definition: the sound that persists in an enclosed space as a result of repeated reflection, scattering after the sound source has stopped. So this means that reverberation will cause like a tiny echo because the sound first directly to the receiver and then it's bounced many times at different angle and it will receive back to the receiver, but this reverberation happen maybe when it is on a big room. If it is small room, you cannot feel the reverberation, but if it is in a big room, you will feel reverberation. It's because of when it is big room, the sound would bounce a lot further. So with the speed of sound of 330 meters per second, your ears almost cannot distinguish the reverberation because it's very fast. It's not even millisecond, it's microsecond different. So when it is microsecond difference, you cannot feel the reverberation. It felt like just one sound. However, when you are talking about very big area space, for example, you are sitting in a stadium alone and you make a shout, then you can hear the reverberation. Okay, so reverberation time, there are a few level. Okay, it takes a sound pressure level to fall by 60 decibel after the sound has turned off. 60 decibel corresponds to a decrease in sound pressure by the factor of 1000. The length of this time depends on the size of the room and the room surfaces, right? Okay, so for example, like in studio, there are walls surrounding you and there are also a lot of furnitures, partitions, walls, and then you have other soft materials like the chair, even the clothes, the bags, or maybe model in the studio. Those are the things that able to absorb and also reflect. Depends. If it is clothes, most of it will be absorbed into the clothes material. But other place like the reverberation of sound may able to absorb at the same time reflect. For example, the material is computer. Computer have a certain absorption rate. At the same time, they have reflection rate. They're all different because material of different. Like keyboards, the computer body, they are all different material, so they will absorb and reflect at different rate. Rooms acoustic. Room acoustic, so you create echo. If you don't have furnitures in it, only walls, then you can echo. Because wall, do not have a very low absorption rate. So that's why it is, if it is you are in an empty room, you will hear a lot of echo. But you are sitting in a room where there's a lot of chair, lot of tables, lot of partition, then it becomes the echo will be absorbed into any kind of material. Yeah. So reverberation versus echo. Reverberation is like this at the bottom. Hello. Then the continuation is because of the factor is the time interval is too close to each other. But echo will be different. There is a distance between the time interval. So you can hear hello, 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 hello. Then that is echo. But when you cannot hear multiple times of clear sound, then it is reverberation. All right. I'm not sure if you get this idea or not. So comfort principle. Background noise is low enough and wanted sound is loud enough for it to be audible, intelligible, enjoyable, and free of disturbance. The sound field is well diffused, free of deaf spot and loud zone. There are no echoes, flutter, shoes, echoes, standing waves, or other acoustic distortion. Reverberate time is appropriate for the purpose and well balanced across the audible audible frequencies. So acoustic comfort, for example, like human speech would be around 500, 1000 to 2000 hertz. The spaces where voice communication, listening to the speech is important, the noise limit can be set in terms of speech interference level. Sound and hearing principle. So when you able to hear sound, your ear will do the work for you. Tympanic and membrane. That is the eardrum. Okay. So your eardrum is always vibrate when they absorb sound. But when they already ruptured, they cannot absorb sound anymore, and you will be deaf totally, unless when you are exposed to those kind of sound, you immediately close your ear. Close your ear immediately, and then just be tenang. Calm yourself. Then you will able to protect your ear. This is very dangerous. Sometimes in the LRT, MRT, sometimes it happen very loud noise when they are braking or turning. When the MRT turn, it will create a lot of noise. And sometimes when the LRT stop, they will open the gate, right, or window. That also for sometimes they those doors opening and close. Sometimes it's very noise. I don't know why, but yeah. So hearing principles. Airborne sound travel through the auditory tube to reach the eardrum, where it starts reverberating. The vibration is transmitted by the ossicles, hammer, anvil, and stirrup. These are in the trio bone in our ear to allow you to hear whatever sound that you are hearing. To the inner membrane and reach to the inner ear, cochlea. 35,000 hair-like ending of the auditory nerve in the cochlea will selectively respond to the various frequency and generate nerve impulses. These impulses are transmitted to the brain to be interpreted by the brain. But first, selection occurs in the inner ear. Ear is function as microphone and analyzer. The most of auditory brain functions involve pattern recognition, filtering out what is relevant, interpretation based on memory, and past experience. That's all for the class today. So we shall continue the about the sound, which is under same topic, but it is about noise and sound mechanism. So there will be 2 more lectures about noise and sound. We will be give out in the next class. I think it's better to give out together, so it will be easier for you to understand. And then the last would be the building energy usage. Okay, so far so good.
Sir,
Yes, do you have questions?
Nash just replied. He said he's really quitting.
Huh?
Nash said he's really quitting.
Quitting?
Yeah,
Quitting the course or quitting the
course.
class? Course.
Yeah.
Oh, okay. We we have not known anything. If he does, he must do it formally. At least we all lecturers know about this. All right, thank you so much, Zimna, for giving this info.
Thank you.
If that's so, then Zimna, you shall work together with siapa nama Nazira for the next presentation. Okay.
Okay.
Regarding the for this one, the second one, you work with Nazira also upgrade the works that is not completed. Okay.
Okay.
Okay, so the next presentation will be on 18th of November. Sorry, we already changed, not to 18. We changed to the other days, right? Twenty-fifth of November.
So it's next week, sir. Next week.
Yes, next week.
Okay.
25th November.
After that, then we need to combine all the 3 presentation together, right?
Yes.
Okay.
So the compilation will be on the 9th of December. You can submit earlier also can, no problem. Okay, so the 25th will be about innovative way to harness energy. So this also still related to the city that you are do studying. Okay. Okay, so for do you have other questions about class? Okay, if there's no questions, so that would be the end of the class today. Thank you so much. We shall see you again next class.
Thanks, sir.
Yep, welcome. So we'll be update you guys in the WhatsApp group whenever, whatever necessary. Okay. So thank you so much. See you again.
Thank you.
Yep. Bye.
Goodbye.